Okay, this video is going to be about the types of variables and graphing data in statistics. This is going to be a video that's helpful for people in any of the Cal Poly Stat Intro to Stat courses, such as 217, 218, or 251. Jumping into that topic, we can split data up into kind of two different categories. We have qualitative data and quantitative data. Going into more detail on what those two categories are, qualitative data is simply data that cannot be expressed numerically. In statistics, there are a lot of different terms that mean the exact same thing, and different instructors and different textbooks will use different terms to describe the same thing. So if you hear the words qualitative or categorical, you can know that those mean really the same exact thing, and I will use them probably interchangeably at different points. And so may your instructor. So it's good to be aware that those are the exact same thing. Examples of qualitative data would be something like color. So colors, if somebody asks you your favorite color, you're not going to respond 7 or 11 or whatever. That wouldn't make any sense. You would say red, blue, green, right? You'd say some kind of category. Thus, this is categorical qualitative data. This is not numerically expressed. Same with class standing or home state. These are things that you're going to answer, or things that are going to be recorded in terms of some kind of category, not in terms of some kind of number. Quantitative data, on the other hand, is data that can be expressed numerically. Again, we have a couple different terms that mean the same thing. So quantitative is equivalent to saying numerical or continuous data. Those are all the same thing. They can be used interchangeably. So if you hear them, try to remember that they mean the exact same thing. Some examples of some quantitative data would be like test score. You can score between maybe 0 and 100 or 0 and 80 or something like that. And that would be expressed as a number, not as just some kind of category. Same with height or weight or income. These are all things that can be expressed numerically. Thus, they would be recorded as quantitative data. So let's jump into an example scenario. Let's say we want to do some research on ice cream, and specifically on the favorite flavor of ice cream of Cal Poly students. So we could ask all of our classmates to fill out a survey, a simple one-question survey where the only question they have to answer is, what is your favorite flavor of ice cream? So think about the question that I have posted there, which is, from this survey, do we obtain qualitative or quantitative data? So take a second to think about that. And what I answered was that this would be qualitative data, right? This is not something that you would answer with a number. Again, you wouldn't say 7 or 11. You'd say mint chocolate chip or rocky road or strawberry or something like that, right? So this is certainly qualitative data. And again, qualitative data can also be called categorical data. So you might hear me say either of those two terms. So let's say we carried out our survey and we asked 100 people what their favorite flavor of ice cream was, and this is the results we got. We saw 32 people said Ben & Jerry's Chunky Monkey, and that's probably not very likely that 32 people would actually say that, but it's my favorite flavor of ice cream, so I decided to let it win in this example. Cookie dough had 29, and chocolate had 28, and then 11 people just said some other. So let's go with this data and then say, how would we be able to graph this data? Because ultimately, once we get some data, we usually want to have some kind of visual representation, right? So we have a couple different options that I'm going to go over. One would be called a frequency table. Another is called a pie chart, and then another is a bar chart. So a frequency table looks like this. Typically in a frequency table, you'll have 3 columns, and then you'll have a row for each of your categories. And then you'll have a row for the total at the bottom. So the first column is going to be what each of the categories are, just kind of listing them out. So here we listed the 4 different flavors of ice cream that people answered. And then the second column is going to be the frequency, or the absolute frequency. So this is just how many people answered in that category. So we said that 32 people said Chunky Monkey, 28 said chocolate, right? So this is kind of simple. We're just filling in how many answered that. And then the third column is something that requires some calculation, but it's very useful, and that's called the relative frequency. So to get the relative frequency, all we do is we're going to divide this absolute frequency, so in this example 32, by the total, which in this example is 100, so we get 0.32. And what this tells us is the proportion of all respondents that answered that category. So in this case, it's not so useful since our total is 100. We can pretty easily say that 32 out of 100 is 0.32. But if we have a total that's like 67 or something, it's nice for you to just be able to have a nice proportion there rather than just looking at like 17 out of 67 or something like that. Advantages of this, we can see both the absolute and relative frequency. As I just said, it's really nice to be able to have a proportion and not just some random number. And then it also gives exact frequencies of each category, so we can see exactly how many people answered in each category, which is not true with some of the visualizations that I'll see later on. The disadvantages are it's really not very visual. It's just kind of numbers in a table. We can't just kind of look at it with our eyes and determine which numbers are bigger. We actually have to kind of think about it and say, oh, well, 29 is bigger than 28 or whatever. The next one is something that probably everybody has seen before called a pie chart. Pie chart, I think you all know how this works, but it's just a circle that you're going to split up into slices or whatever you want to call it that are proportional to the relative frequency of people choosing each category. So this percentage of people chose Chunky Monkey, this percentage chose cookie dough, this percentage chose chocolate, etc. Advantages of this one, it's a nice visualization of the relative frequencies, so I can see that here somewhere more than a quarter of people, but less than a half, probably around a third of people chose this category. Same with this. This is smaller, maybe like 10% or something like that, so I can kind of see the relative frequency of each group. Disadvantages, it doesn't work well if you have a lot of categories, so if we had like 12 different flavors of ice cream listed here, this visualization would start to look really crammed and it would be hard to look at and hard for us to compare. So this really only works when you have like 4 or 5 categories or less. It's also hard to compare the frequencies of different categories. So if I look at this chart here, I can very clearly see that this slice of Chunky Monkey is a lot bigger than the other slice. So I can compare that, but it's pretty hard for me to compare Chunky Monkey versus cookie dough versus chocolate. It's hard for me to tell which one of those is bigger. Which going into the next example, a bar chart, you see here we have a lot better ability to compare these categories and see which one is bigger than the other. So this is a bar chart, and again, this is probably something you've seen. In this case, we have, instead of a slice for each category, we have a bar, which its height is the height or is representative of how many people chose that category. Advantages of a bar chart, it's very easy to understand. We can look at this easily and see that if this bar is higher, then more people or more subjects are in that group. And it's also very easy, as I just said, to compare categories, right? I can see that Chunky Monkey is higher than cookie dough is higher than chocolate, chocolate's higher than other. I can easily tell which group has more responses than other groups. The disadvantages are that it's very difficult to see the relative frequency. So I can look at this and see Chunky Monkey was the most picked flavor here, but I can't really see what percentage of people said Chunky Monkey. It's hard for me to look at this and know what percentage of the whole chose that. So that's something that a pie chart can kind of tell us that a bar chart really cannot. Okay, let's go into a different example here. This is going to be still on the topic of ice cream, but now instead we want to research how often people eat Ben & Jerry's Chunky Monkey ice cream. So now we're going to ask them, in the past month, how many times have you eaten Ben & Jerry's Chunky Monkey ice cream? Again, try to answer this question. Is this going to be qualitative or quantitative data? Take a second to think about that. I said that this is quantitative data, right? This is going to be expressed numerically now. Somebody's going to answer that they ate it 0 times or 5 times or 100 times, right? So this is going to be something that's quantitative, numerical, continuous. Again, those terms all mean the same thing. So let's say that we carried out this survey and we asked 100 people, and this is the data that we got. We saw each of these numbers is representative of one response. So one person said they ate it 0 times, another said 0 times. Somebody down here said they ate 53 times in the past month they ate Chunky Monkey. That's a little bit concerning. That was probably me. Another person said 20. Again, that's fairly concerning that they're eating that much Chunky Monkey. But nonetheless, this is the data that we have. How are we going to be able to graph this data? Because right here we just have a bunch of numbers, and that's neat, but it's kind of hard for us to look at and hard for us to draw conclusions from. So we want to graph this quantitative data, and we have a couple options. We have a histogram, a box plot, and a dot plot. So a histogram looks very similar to a bar chart, but it's not the same thing, which is important to think about. So in a bar chart, we have discrete categories where each bar represents one category. In a histogram, we instead have basically bins. So this bar here is going to represent everybody that answered between 0 and 5, or I guess 0 and 4. This bin here is going, or this bar is going to represent everybody between 5 and 9. This is going to be everyone between 10 and 14, etc. So these aren't actually representing a single number, they're basically representing kind of a range of numbers. So we can set these bin widths however we want, which is something that's kind of tricky. Sometimes you have to think about how big or how small to set your bin widths. But a histogram is a very nice visual for us to look at the distribution of our data, right? We can see that the far majority of people answered a relatively low number, and then we had this kind of one outlier up here, me probably, who somehow ate 53 servings of Chunky Monkey in 1 month. So advantages, we can look at the distribution of the entire data set, right? So we can see all of the data that's here, and we can see roughly how it's distributed. We can see that the majority is over here in the far left, and then we have this one little bit out here. Disadvantages, it can be hard to determine the mean or median from this. I look at this and I really don't know like what the average amount is or what the middle area is. And I have another video I'm going to do on what mean and median are. And then changing bin width, as I just said, you have to decide how wide to make your bins. So I could have made my bins, right here they have a width of 5. I could have made them have a width of 10 or of 1 or of 2.5 or whatever. So we have to make that decision, which can be difficult, and it can give a different image of the distribution depending on what you choose. Another option we have is a box plot. This is kind of a funky looking box plot here. Normally this part here, which they call the whisker, normally we have one on both sides. But essentially what the box plot shows us is it's going to give us kind of the 5-number summary. So it'll show us the maximum here. This is going to be called the third quartile. This is going to be the median somewhere in here. And then we're going to have the first quartile here, and then usually we have another whisker that shows us the minimum. And then these here are outliers. So this isn't honestly a very good example of a box plot, so if you are confused about this, feel free to ask me questions and I can give a better example. Advantages of a box plot, we see those summary statistics, the maximum, the minimum, the median. It's very easy for us to see them and to look at them, which is nice compared to the histogram. We didn't really have that ability. We can also see the spread of the data, so we can see how far out the data is spread. The disadvantage is that we only can see the summary statistics, right? We only see that the maximum is here and that the third quartile is here, but we don't really know how the data is spread out between here. Versus the histogram, we can kind of see all of the data a little bit better. And then another example is a dot plot. This is one that doesn't get used that often, but I kind of really like. Here we basically put one dot on our graph for each response that was in that area. So you see these dots here are all the zeros. These dots here are all the ones. We have this one dot way far right over here, which is me eating Chunky Monkey 53 times. Advantages of this, we can see every single data point on here. So we don't have any questions about what's between the median and the third quartile or anything like that. We can see every single response on this one visualization. Disadvantage, it can be very time consuming to make one of these, especially if you're doing it by hand. You have to draw a bunch of dots. That's kind of a pain. It also doesn't give us the summary statistics, which is the same deal as a histogram. We can't really see what the mean is or the median or anything like that. Okay, so in summary of this video, we talked about the two different types of data, qualitative and quantitative, and the different terms that can be used to describe those two categories. Qualitative data, we talked about frequency table, pie chart, and bar chart, which are 3 examples of how to graph qualitative data. And again, there's more options out there than just these 3, but these are 3 important ones to know. And then there's quantitative data. Here's 3 ways that we can graph that data: histogram, box plot, and dot plot. A couple of review questions. Pause if you want to answer these yourself. I'm going to go through the answers right now that I responded with. So the first question was to classify each of the following as quantitative or qualitative. Favorite color, that would be something that's qualitative, right? We can't put a number on that. We can't express that numerically. Income, on the other hand, would be quantitative. That's answered numerically. You make, $2,000 a year, or $50,000 a year, or $1 million a year. That's some kind of number that we can use to express that data. Major would be qualitative. That's not a numerical response. That's some kind of category. I'm an architecture major, or a business major, or an English major, right? SAT score, this is something that's quantitative. You score 400 or 300 or 800 or whatever. This is something that we can express numerically. Okay, the next question, if I collected data on the height of 43 Cal Poly students, which would be an appropriate way to display this data? So thinking about this data here, we're collecting data on height. So this is going to be quantitative data, right? Since height is going to be expressed numerically. So we need to think about histograms and pie charts. Earlier we said histogram we can use to graph quantitative data. Pie chart we use to graph qualitative data. So in this case we would use a histogram to represent our quantitative data here. Next question is, we're collecting data on the preferred political candidate of 43 Cal Poly students. What would be the appropriate way to display this data? Well, now in this case we have qualitative data, right? We're not answering our favorite political candidate as a number. We're answering that as some kind of category. Right now, in terms of like the presidential race, we kind of have three choices. Donald Trump for the Republican side, and then Joe Biden and Bernie Sanders are kind of the choices on the Democratic side. So you'd answer as one of those three choices, or some third-party candidate or whatever. We wouldn't answer that numerically, so this is qualitative data. And we said earlier that pie chart is how we represent qualitative data, so pie chart would be the answer to that question. All right, thank you.